Okay, we're back. So let me illustrate what I mean by focusing on delta x. We've got this function, we've got our base point, and then I'm going to exaggerate drastically how far delta x is going to go. Let's say I go all the way to 7, which is ridiculously huge. Then I can focus on the fact that I'm comparing the value at 5 for the temperature and the value at 7 for the temperature. But I can also focus on the fact that I'm starting at 5 and walking 2 units to the right. And in some ways that's a better perspective. That's really the interesting thing, is how far I go away from the base point. So that's the delta x, whereas that was x itself. And if I move x, I move delta x. If I change delta x, I move x. And they're related in a very simple way. The x value is just 5 plus the delta x. It's just a matter of how you do the bookkeeping. So now, we're going to rewrite this. We still got our 5 and 300 as our base point. And now, I'm just going to try to write everything in terms of 5 plus delta x. I start at 5. I walk a specified delta x to the right. But I'm thinking of a small number, 0.1, 0.01, something like that. And then I'm going to plug that into here. And at first it's going to look like a bad idea, because it looks like it's a little complicated. That is the y value at that point, 5 plus delta x. And it looks a little more complicated than what we had before. But there are some real payoffs to it. But now we're going to do exactly the same thing. Delta t over delta x is just combine that variable point. And again, this is just a fancy way of putting together all these weird numbers that we would have seen in the numerical method. Compare it to 300. That's the rise here. That's delta t. And then divide by delta x. Now again, in the book, the first time they bring this in, they think they use h instead of delta x. And that's a little friendlier because it's a single letter. You have to remember that delta x is not the quantity delta times the quantity x. It's just one quantity, the change in x. It's a little bit weird way to write that, but it's a very popular and very, very powerful way to write it. But h is a perfectly good way to write that with a different letter. And now what we're going to do, we're going to take the limit as delta x goes to 0 again. So now the algebra, instead of factoring, it's expanding. You've got a binomial to expand. So we get 5 squared plus 2 times 5, which is 10 times delta x, plus delta x squared, all times 4 minus 300, all over delta x. Okay, so 200 plus 100 minus 300. Hey, that's interesting. That's 0. That all cancels. 4 times 10 times delta x. Woo, woo. I've seen that number before. Plus 4 delta x squared. And here's one of the payoffs here. It doesn't take nearly as much ingenuity to see that these cancel out. We got to be careful though. You don't want to do what's called partial cancellation and just like cancel this against this and leave this alone. To do it carefully, what we're going to do, I'm going to do it in place to save space on my limited board here. So I'm going to factor out that delta x. If you factor out, and it's a factor of everything on the top and everything on the bottom, well of course it's on the bottom, everything on the bottom because it's just delta x on the bottom, then you can cancel. And now look what I'm doing. I'm taking the limit as delta x, this quantity is going to 0, of 40 plus 4 times delta x. That's certainly a polynomial in delta x. As delta x goes to 0, that just goes away. And that's another way to get that magic number 40. So again, it's just an algebraic way of systematizing what we did before. And it's a little bit of algebra, it's a little unfamiliar, but we'll get practice on it. But it really is just a more efficient way, and a much more general way, and powerful way, to do the tabular numerical method we did before. We get exactly the right answer, and we're sure of it. We don't have to guess and hope that it's correct.